Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, class? Today we will continue with the seventh type of layout, as you know, which is product-oriented layout, repetitive and product-oriented layout. Also, again, we have discussed this before, but it was not in details. Today we will discuss it in details to continue with our chapter and with our slides. Today will be a very short, lecture because I will discuss the product-oriented layout theoretically. Okay, the theoretical part. Now, next lecture we will discuss the computation, the calculation part. Okay, with the example, of course, with actual example, because this type of layout very important. Okay, and it has a calculation, and it's very important also for your exams and so on, and it's very also important for the practical life in operations, production and operations management. Now, as you recall, when we discussed this before theoretically, I remind you at that time, I remember that the manufacturing company, most of them, they use the repetitive or the product-oriented layout. If you recall, Harley Davidson, for example, they use the repetitive process strategy, and Frito-Lay, they use the product process strategy. So it is good also for you. I am reminding you also with chapter 7 when we discuss the four process strategies, which is the process focus strategy, the repetitive focus strategy, the product focus strategy, and the mass customization strategy. Okay, so this will be related now with this in the layout. The repetitive layout and the product oriented layout, they are related to each other. So always remember the example, okay, or the flow chart of Harley Davidson, and try to remember also the figure that we discussed in chapter 7 with regard to the Frito-Lay as another example for the product oriented layout. Anyway, now in this type of layout, you have to take note that your products, okay, or your equipments or your product line or assembly line should be organized around products or family of similar high volume, low variety products. And you know that of course, in repetitive, we have always a medium volume and a medium variety, but in product process strategy, if you recall also from chapter 7, it was high volume, low variety, like in the Frito-Lay. Okay, now volume should be adequate for high equipment utilization. Now, since your equipment, the fixed cost for your equipment in the product oriented layout is expensive, I mean it's costly, and the fixed cost will be high, then you should have a massive production. That's why we said that volume is adequate for high equipment utilization. In order to reduce your fixed cost or your total cost even, you have to produce in high volume. High volume means high number of units. You should be massive production in order to reduce your cost, because your equipment should be utilized well. Now, product also demand in the second point is stable enough to justify high investment in specialized equipment. This is again another point. In the product demand, if the demand is low, then you cannot have a high volume of production. That's why you have to make sure before you use this kind of layout that you have a high volume or a high demand, sorry. And this will be, of course, this will depend on the way you make forecasting. That's why your forecasting your demand forecasting should be accurate in order to assure that you will have a high demand, because you should be a massive you should have a massive production here. Now, in point number 3, product is standardized or approaching a phase of life cycle that justifies investment. يعني in a way, if you have only a new product and it's not yet really, it's not so much standardized, okay, then you cannot again have a massive production, then you cannot use this kind of layout, because as I told you, you should the life cycle, يعني at least you can use this kind of layout in the right stage of the product life cycle. هلا in the growth stage, okay, and in the maturity stage, of course, it is advisable in manufacturing to use this kind of layout, because your production will be high. At the same time, of course, you're based on your high demand. Now, supplies also of raw materials and components are adequate and uniform quality, since the system of production, product oriented layout, is a continuous system. يعني the production is a continuous one, unlike the process unlike in the process oriented layout. In product oriented layout, it's a continuous system, it's not an intermittent system. Okay, then you have to make sure that your materials will be there, raw materials, the needed raw materials will be on time, and it should be with the same uniform quality. Okay, why? Because you cannot stop your product lines, your production is continuous, then you need reliable suppliers in terms of the time of delivery for the raw material, and of course in terms of the quality of your raw material. Now, also we have to differentiate here between two lines in manufacturing companies. We have what we call a fabrication line and assembly line. And by the way, fabrication line خط التصنيع, wherein the assembly line خط تجميع. خط تصنيع, خط تجميع. Now let's compare between them and differentiate between them, and it's very important for you as a student to differentiate between the two lines, the fabrication line and the assembly line. Let's start with the fabrication line. For example, builds components on a series of machines. It builds components, يعني نفس component needed to be assembled, it should be تتصنع بالأول قبل ما تبدأ بتجميعه. Okay, so and it is machine based, يعني it will depend always, the product oriented layout will always depend in terms of fabrication line. Fabrication line is always depending or focusing on the machines itself, unlike you will see, unlike in the assembly line, it will be based on the workers, in the work tasks. Okay, also the fabrication line require mechanical or engineering changes in order to balance your fabrication line. To balance it means in order to reduce the in-process inventory, as I told you. Okay, in order to assure the continuity, يعني in order to assure that your system of fabrication or the system of manufacturing will be continuous. Then in order to balance the work, okay, and between stations, let's say, then it should be balanced in a way mechanically or by engineers. Now we will see the difference when we talk about the assembly line. For example, in assembly line, it puts the fabricated parts. Which parts? The parts that you build it here, الcomponents. انت عملت components, صنعت الداشبورد مثلا for the car. الداشبورد الكومبوننت هذا انت بتصنعه وين؟ على الفابريكيشن لاين. بس وين بده يروح بعدين؟ بده يروح على الاسمبلي لاين عشان يتجمع. اوكي، الباب نفس الشيء، باب السيارة, the door of the car, you will always have it you will have it first in a fabrication line, تصنيع, then it will go to the assembly line. That's why we said in the assembly line that puts fabricated يعني parts, القطع المصنعة, together at a series of workstations. And this is what you do in manufacturing airplanes or cars or even motorcycles. احنا في الموتورسايكلز لما نتكلم انها بس اسمبلي لاين، طب البارتس هاي اللي بدنا نعملها اسمبلي وتجميع وين بتكون صنعت؟ على الفابريكيشن لاين. Okay, now here also another difference as you noticed. هلا in the fabrication line it's machine based, but in the assembly line based by work tasks. Okay, and the balance, you will balance your assembly line by moving tasks from workstation to workstation, because you will see later on, maybe next lecture, when we discuss our example and solve the quantitative example, I will show you how to balance your assembly line in a way by changing or moving tasks between workstations, and we will learn how to calculate for the number of workstations needed in each assembly line. Now both types of lines must be balanced so that the time to perform the work at each station is the same, and this is very important so that we will not have, again, as I told you, in process inventory, and you know, in assembly lines and product lines, if any breakdown will happen in any workstations, then it will stop the whole line. Okay, we will talk about it further now. What are the advantages of product-oriented layout with compare, of course, to other layouts? Low variable cost per unit, and this is very important. Low variable cost per unit. Why? Because the number of units that we are producing is high, and we said you cannot really use the product oriented or the product focused strategy or the product oriented layout unless you will be a massive production, yani unless you are producing in high volumes. Number two, low material handling cost. The material handling, the cost will be less. Why? Because our system is continuous. At the same time, in number three, this type of layout will reduce the work in process inventories. هاي اللي ضليت احكي لك عنها، انه ما بصير في تاخير، انه المرحله معينه اذا كانت سلو بتاخر المراحل بعديها. هلا في هذا السيستم if you do it right, if you design your product oriented layout يعني in the right way, then you will reduce the in process inventories. And also another advantage, easier training and supervision, because you know in the process it's very difficult to train people because you need employees with you need highly skilled people, persons, labor, and also supervisors. But in this kind of layout it's easier for you to train them. Yani even though that, for example, you have a new equipment in your product lines, or you design a new product line, let's say for Pepsi or Coca-Cola, or yani Pepsi or Coca-Cola, whatever. If you have a new product line, you know the line will work automatically. Then it's easy to train employees how to deal with the new equipment. It's easier than, for example, the process layout. And of course, your process, okay, the process will be fast. The throughputs, we call it, because you have input, throughputs, and outputs. Your throughputs, your operation will be faster than the other types of layouts. Disadvantages also, you know, everything has, or each type of the layouts has an advantage and disadvantage. One of the disadvantages is high volume is required. Again, yani this point we repeat it 100 times. If you don't have volume, if you are not yani a massive, if you don't have a massive production, then you really it does not worth it, let's say, okay, or it's not efficient for you to use this kind of layout. So you have to assure the high demand and high volume in order to use this kind of layout. Number two, work stoppage at any point ties up the whole operation. I have mentioned that. Now, if you recall also with me, when we discussed the process oriented layout, we said, any problem, any breakdown, okay, with any equipment will not halt or will not stop the whole operations. Why? Because you can transfer work to other departments. But here in the product, in the repetitive and product oriented layout, no. عندنا workstation, 6 workstations, let's say in one product line. إذا one of the workstation مثلا عملية تجميع let's say ابواب السياره مثلا في يعني ستيشن let's say work station number 3 اللي عندها بصير تركيب الابواب، اذا وقفت حتوقف كل البرودكت، حتوقف خط الانتاج كله، لانه كل الخطوات اللي بعديها والستيشنز اللي بعديها it will stop also. And this is one disadvantage. This is one really of the major disadvantage of the product oriented layout. Another disadvantage, which is the lack of flexibility in product or production rates. Why? Because in the process you don't care. In the process layout you don't care because your volume, we know that your volume is low but your variety is high. But here in the product oriented layout and in the product also focus process or focus strategy, your let's say your flexibility or your volume, let's say, is high but the variety is low. That's why the rate of production should always be high, as we said a while ago. And this is a problem. You cannot be flexible. You will say, no, today I will produce only 100 units. That's enough. No, this is a system. Your fixed cost, your investment in the equipment is high. That's why you have to assure that you will always have high volume, because the rate or the average of production, the daily production or the monthly production or the weekly production is not flexible, unlike the process-oriented layout. Okay, let's see, for example, even يعني some people, this is a service company, McDonald's, even McDonald's. Now the burger that you are buying from McDonald's, البيج ماك, let's say البيج ماك ما هي بتمر في process في workstations, as you can see here station number 1, which is the order read on a video screen, station number 2 التوستر, station number 3 الcondiments, station number 4 let's say الheated cabin for the grilled, let's say patties and so on, heated let's say landing pad will be in station number 5 and station number 6 and so on. So you see there is also an assembly line, assembly for the Big Mac, for example. And don't forget, this is what I was talking about, task times. You know, each task at each workstation has a task time, like we see here. For example, step number 1, which is the order, okay, without time, 0 time. But for example, the bun toasting in workstation number 2, you need 11 seconds, okay, and you need for example 20 seconds for the assembly with the condiments اللي هي الامور الاخرى اللي بتحطها مع البرجر. وعندك الرابنج of the patty with the bun, you need 14 seconds and so on. So each task at each workstation has a task time. That's why we will learn when we will discuss our quantitative example, the calculation example, next meeting inshallah, next lecture, we will see, you know, how long your product could stay in one workstation, okay, which we call the cycle time, and we will talk about it. Anyway, how we do the assembly line balancing, how we do the balancing for the assembly line, so that I told you, first of all, we will reduce the in-process inventory. At the same time, we will make sure that our product lines our entire operation will not be halt or stop. Okay, that's why we have to balance our assembly line. Of course, practically, we will learn how to balance our assembly line next lecture with our first example. Okay, but today we will discuss this theoretically now, but I assure you, don't worry, you will understand this more when we apply our example next lecture. So next lecture you have to focus on the video so that you will understand how we deal with these theoretical things. Now, the objective in the balancing is to minimize the imbalance between machines or personnel while meeting required output. انا ما بدي والله ورك ستيشن تكون سريعه وبعدين البرودكت عندي لما يوصل لورك ستيشن 2 يتاخر. ما استفدت. كيف بدي اعمل بالانس بيناتهم؟ This is what we are going to learn next lecture inshallah, practically with numbers. Okay, now also the assembly line balancing starts always with the precedence relationships. You will notice also from our example next meeting that what we will start with, we will make the precedence relationship between the different tasks. For example, even in McDonald's, even a while ago, and I show you in the McDonald's example, for example, you cannot start with task number 4 before you do number 3 sometimes. But sometimes in some manufacturing companies, now some tasks are related to the other task. يعني انت مثلا حتى في الكونستراكشن تقدرش تبدا تدهن الا اذا عملت كساره بالاول. هذه هي البريسيدنس ريليشن شيب that we will talk about it also in our lecture next meeting with our practical example. Now you have, in order to do the assembly line balancing, you have to determine what we call إشي اسمه cycle time, the one I mentioned a while ago. Cycle time, what is it? يعني بدنا نعرف the cycle time is the maximum time that your product could or is allowed to stay in one workstation. يعني مثلا workstation number 4, our product لما يوصل عند workstation number 4 is allowed to stay, let's say 12 minutes, so, or 14 minutes. So this will be our cycle time. Less than 14 minutes, it's okay. But more than 14 minutes, for example, if the cycle time is 14, of course, it's not allowed. Why? Because it will delay the entire operations, the entire assembly line. Also, you have to calculate the theoretical minimum number of workstations. As you say here in the figure, there are workstations. يعني الايربلين بتمر، شوف كيف مارين ورا بعض، بنتقلوا من workstation لwork station. هلا also in our example next meeting I will show you how to calculate how many workstations do I need. Of course, this will depend on the number of tasks that you have and on the sum in the total task times for all tasks. We will take it into consideration, and it will depend also on how many units do you have to produce in a day. Don't worry, we will apply this practically also again next lecture. And of course, the balancing the line by assigning specific tasks to workstation. As I told you, each workstation will combine maybe one task, maybe two tasks, maybe three tasks. So it's your work now as an operation manager to assign how many tasks we will have in this workstation and how many tasks we should have in the workstation number 2, in workstation number 3. We will learn, okay, together, me and you, how to assign the tasks to each workstation. Task A and B, for example, in workstation 1. Task D and E will be in workstation number 5. And of course, this will depend on the cycle time. Don't forget that we should not exceed the cycle time. We will learn all of this practically, inshallah, with the first example next meeting. Next meeting, please try to review this example, at least to have an idea about it, so it will be easier for you to understand and to follow with me next lecture with this example. It's very important example, as I told you. It will help you a lot in your also in your final exam. Okay, and this ends our lecture for today. We will start with this example inshallah next lecture, because if we will start with it now, maybe it will take time. So I prefer that it's better for us, I think, or for you, to start with this example next meeting. Until then، بتمنى لكم السلامة جميعا. Thank you very much.